Okay, this is a lab for the second FEM part, and also lab 7. Today we're gonna mesh uh, the polygon we modified from last lab. So here's the plan for the later half of the semester. We have lab 6. We did some modification on the idealized part. Then lab 7 we're gonna make the mesh. Next week we're going to do the FEM assembly, and last lab we are going to apply boundary conditions, loads, then we're going to run the model. So today it's very fast. You should have this from lab 6. Then first we're going to mesh all three pieces into 2D mesh. So make sure you have the piece of the jaw handle that is cut. There's a cut on the jaw handle, so you don't want to use that piece to generate the 2D mesh. Okay, now let's start with the 2D mesh, and type quad 4 as it says here, and the size is 0.05 inch. You can check this. Then we want to mesh them one by one. So first piece and apply. Okay, it'll say something the element type or element quality is not very good because this the violated this that but it can still run. It's just not a very good quality, but in terms of our class that's totally fine. So we have one piece in the 2D collector, then we need to mesh the other piece exactly the same parameters, and also you want another collector, so you need to make sure this one is checked, auto creation. So apply. Now we can apply for the third piece. So that's all for these three pieces of mesh. If you would like to, you can change the name. Okay, rename, and that's jaw handle. The second piece, I think that's the link. The third piece is our grip. So I accidentally double click. It's the same thing. Okay, and as you can see, I have different colors here. How to make that? You can right click on the collector, edit display. So I think this one is this. So I'll use the first color, apply, and the link. Okay, any color you like. Might be this one. The last one is red. Okay, so that's all for the 2D map, a 2D mesh. Then next is our 3D mesh. Again, that's the same size, and that's the tether, 3D tether, and we use linear tether because those two pieces are relatively strong in this jaw handle, in this whole model. So if this model deforms, the bigger deform will be on the deformation will be on the handles instead of the solid parts here. So it makes little difference if you use a parabolic or a linear tether. That's why we just need to use this. So for both of them, they're 0.05 inch, and you don't have to play with those. Let's say apply for the first one, then pick the second one, also auto creation, then apply. Alright, now we have two pieces of mesh, 3D mesh. You can rename them. I'm gonna skip that, and you should have two different collectors. You can also change the color if you'd like to. Then the next step is the screw hole for the screw on the jaw handle. So if you look at this piece, where's that? I think I had hide those here. Anyway, so if you look at the actual polygon for the jaw handle, there's a cylinder here. Okay. However, on the mesh we don't have that. So for this piece, the midface is also disconnected from the midface of your jaw handle. So we don't use that. We just simply extrude this edge, okay, into a mesh. So how do we do that? We insert element and extrude. And we're going to extrude this edge. So I would like to pick this element edge. And of course you can hand pick this, but we have this method here. We can use feature element edge and pick one of the edge on this long edge, and they will be picked up. Then this cylinder is 0.3 inch long, so I have 6 copies of the mesh, and per copy is 0.05, which is exactly the same size of the 2D mesh on this piece. Okay, so that'll make them match each other. And the tricky part is the vector, which direction you want to extrude this. And this is not on X, Y, or Z. That's kind of tilted axis or the vector. So we need the help of the polygon. You can use either the screw or this one. As long as you have that cylindrical face, you can pick. So when you click here, define the vector, and you can pick either cylindrical face. I'll pick this one. And the direction, we need to flip this to extrude the other way and apply. Let's hide the polygon. So that's the extruded part. Okay, and since this is extruded, this piece of mesh and this jaw handle mesh, they are connected. Okay, so there's no duplicate nodes along this edge, which means if you do a simulation, the computer will think they are a single piece of mesh. Alright, now that's all for this half of the whole model, if you look from this direction. Okay, and now we need to reflect this everything to the other side. And as we said in lab 6, the advantage of this will be you can apply force on the symmetry plane, because we made we mesh on the symmetry plane, so we will have a line of face of nodes on the symmetry plane. If you simply just mesh the whole piece, you're not guaranteed to have like one node right on the symmetry plane. And also you can have boundary conditions applied dead on the symmetry plane. That's why also the whole thing is symmetric. That means if you apply symmetric boundary condition, you would have symmetric results. Alright, insert element, copy and reflect. And here one thing to notice is we don't need to reflect the link because it's in the middle. So we can hide that piece here, and also we don't need polygons. So that's everything we need to reflect. You can just box select everything, and the numbers of the elements, it changes. Sometimes and you probably have a little bit more than this. So it depends on your computer, or I don't know. And the reflection plane is XY plane, so you need to pick that ZC. That's your symmetry plane. Say OK. And now that's the everything. If we turn to Y-frame, you can see clearly there's an edge in the middle that indicates those are two meshes. I mean, but if they're connected or not, it's the other matter. So let's take a look. So since we reflected everything, okay, we also reflected the nodes on the symmetry plane, or the edge, the nodes on the edge of the symmetry plane. That means we have, for example, this spot, we have two nodes. Okay, one is on the original copy, then the other one is we reflected. So we have duplicated nodes on the symmetry plane. And also, since the nodes here, one belongs to the other one side, the other one belongs to the other side. That means those two meshes are separated. If you apply a force here and you pull that thing from the other direction, they will separate. And how do we combine those two together? How do we check if they are a single piece or not? We can use element edge. That's a tool to check the external edge of mesh. So pick everything and generate element outline. And as you can see, we have an outline in the middle of a mesh. So it says this edge is outside of this mesh. That means they are separated. Okay, you do not want to see an edge inside a piece of mesh if you think that's a single piece. So what do we do? By the way, if you want to take out the blue line, you can just refresh. We merge duplicated nodes, and we pick everything, and it should show us the those nodes that's a duplicate. And sometimes, you can, if there's something missing, you can play with the tolerance and hit enter. You do want to merge all the nodes that are on the symmetry plane. Sometimes the tolerance is different. So 0.01 is a good tolerance, and merge the nodes. How do we know it's merged? We're gonna do another edge, element edge check. Pick everything and generate outline. Now this time there's no edge in the middle, which means now when you run a simulation, this is a single piece, or those two meshes are connected. Okay, and that's all for this lab. It's kind of short, but we do have homework. So you need to know some of the basic concepts in the process of the FEM, and also you need to write up the steps so far from lab 6 to lab 7. So eventually you can put this homework into your final report. Alright, that's all. Thank you.